This video will cover the homework questions 4-14 to 4-19. 414. Solve this problem by writing and solving an equation. Be sure to define your variable. A rectangle has a perimeter of 30 inches. Its length is 1 less than 3 times its width. What are the length and width of the rectangle? So we need to define our variables, which means we need to write let statements. So we can start off by saying let x, or in this case, since it's length and width, we're going to say let w equal the width, and that is measured in inches. Alright, we know the perimeter is equal to 30 inches, so also remember that perimeter is twice the length plus twice the width. And it says its length is 1 less than 3 times its width. So the length 1 less than 3 times its width would be 3 times the width minus 1, and that would actually represent the length in terms of W. So to set this up, we can say that the perimeter, which it tells us is 30 inches, so 30 is equal to twice the length, length being 3w minus 1, plus twice the width. And so there's our equation. So what are the length and width of the rectangle? We need to distribute 6w minus 2 plus 2w. Add the 2 to the 30, and that will give us 32 equals 6w plus 2w is 8w. Divide by 8, and the width is equal to 4 inches. To find the length is 3w minus 1, so if that's the case, we can plug in 3 times 4 inches, and that would be 12 minus 1, which would be 11 inches. So what are the length and the width of the rectangle? We need to write that answer out, that the length is 11 inches, and the width is 4 inches. So make sure you answer the question also. Question 415. The basketball coach at Washington High School normally starts each game with the following 5 players: Melinda, Samantha, Carly, Allison, and Kendra. However, due to illness, she needs to substitute Barbara for Allison. So Allison is going out, Barbara's going in, and Lakeisha for Melinda. So Melinda's out, and Lakeisha is in. At this week's game, what will be the starting roster for the upcoming game? Well, now that we've replaced Melinda and Alicia, the starting roster will be Lakeisha, Samantha, Carly, Barb, and Kendra. And so once again, make sure you answer the question. On problem 416, when Miss Shreve solved an equation in class, she checked her solution and it did not make the equation true. Examine her work below and find her mistake. Then find the correct solution. So we're trying to figure out what the error is in the problem. One way you can do this is to actually do the problem off to the side, not looking at what that person did, and see if you can find the mistake that way. The other thing is just going through and asking yourself, what should they do? Distribute 10x minus 5 minus 3x equals 5x plus 9. So that looks good. Then you should combine your like terms. 10x minus 3x is 7x. So that one looks good. How'd they go from this step to this one? Well, they didn't show their work, so you have to be careful. So let's go ahead and get our problem down to that same point, and then maybe we can show work and see if they made any mistakes. So we got 7x minus 5 equals 5x plus 9. So on this, normally what we would do is get the variable on the left, so subtract 5x to both sides to get 2x. And then you could add the 5 to both sides to get 2x equals 14. So they got 12x equals 4. And you can maybe see where that came from is the 7x and the 5x would add to 12x, but they're on different sides of the equation. Same thing, negative 5 plus 9 would be a positive 4. But once again, they're on the other side of the equation, so you have to add or subtract them. So that's where the error occurred. Really on step or line number 4 is where the mistake was. And then we can finish ours over here, divide by 2, and x is equal to 7. So examine her work below and find her mistake. We found her mistake, which would be line number 4. And then find the correct solution, and we say it's x equals 7. It doesn't tell us to check it, but we could plug it back in and check to see that it works. And on this one, it definitely will. 417, determine if the statement below is always, sometimes, or never true. Justify your conclusion. So it looks like we can start to figure out what is going to happen when we solve it. And we get 6 plus 5x, which is not actually correct. It's 6 plus 10x. Make sure you distribute to both terms. And then we can get the variables on the same side, so subtract the 5x. That would leave us with 6 plus 5x equals 6. Subtract 6 to both sides. And we get 5x is equal to 0. Divide by 5. You can divide 0 by a number, a non-zero number, and so 0 divided by 5 is x equals 0. So determine if the statement below is always, sometimes, or never true. Well, what do we know? We know at x equals 0 it'll be true, but anywhere else it will not work. So this is sometimes true when x is equal to 0, but otherwise it will be false. So for any other number besides x equals 0, it would be a false statement. So once again, that is a sometimes true. Sometimes it'll be true when x is equal to 0, and then sometimes it'll be false when x is equal to any other number. 4-18, find an equation for the line passing through the points. We've done this one numerous times, and so we'll do it once again. First thing we need to do is find the slope. Make sure you are taking the change of your y's divided by your change of x. So 1 minus 7, negative 3 minus 9. So negative 6 divided by negative 12, which reduces to 1/2. So we have your slope. We don't have the y-intercept, but we have a point. And so I'm going to use the point 97. Plug in all the information we know. Y is 7. Slope is 1/2. X is 9. And then we're going to find the b value, or the y-intercept. So 7 is equal to 4.5 plus b, or 9/2. And then subtract 4.5 from 7. And that will be 2.5, or the same thing as 5/2. So your equation for a line going through those 2 points would be y equals your slope, which is 1/2, times x, plus your y-intercept, which I wrote as 5/2, or you could write it as 2.5. And the last question, multiply each polynomial, that is, change each product to a sum. So we have two different ones here. This is where we can use our generic rectangles and set up our side lengths. This would be 2x plus 1, and then we have 3x minus 2. Multiply each of the individual parts. This will give you 6x squared minus 4x plus 3x and minus 2. And then to multiply the polynomials, we're trying to find the, we're changing, I guess, be careful here. It's written as a product and we want to write it as a sum. So therefore, I'm going to write all this out. 2x plus 1 times 3x minus 2 is equal to 6x squared. Negative 4x plus 3x is negative x. And then minus 2. So 6x squared minus x minus 2. So just a reminder, this is the product which are your dimensions, is equal to the sum of its parts. On part B, your generic rectangle has a little bit more to it. We have 2x plus 1 as one of the side lengths, and then the other one has 3 terms. We have a 3x squared minus 2x minus 5. And we do the same thing we did on the other one. We multiply it, so 3x squared times 2x would be 6x cubed. So you're adding the exponents, and then negative 2x times 2x would be negative 4x squared, and negative 5 times 2x would be negative 10x. And then we have 3x squared times 1, negative 2x squared times 1, and negative 5 times 1. So if you look, just like you could combine these like terms on the first one, you have something similar. You have these two, and then you also have these two. So when we go to combine these, we're going to get the original, which was 2x plus 1 times 3x squared minus 2x minus 5 is equivalent to the sum of all its parts. So 6x cubed, nothing can be added to it, no like terms. 3x squared minus 4x squared is minus 1x squared, or minus x squared. Negative 2x minus 10 is negative 12x. And then the constant at the end, negative 5. So that whole thing is multiplying your polynomials and getting the sum of its parts.